Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to take a look at two string functions that search for patterns in strings and return a Boolean output. These functions can be used as you build searches and rules in Google SecOps. If we had a pattern and wanted to search for it anywhere within the string, we could use the function strings.contains. If we find it, a Boolean value of true is returned. If it isn't, then false is returned. The syntax requires two arguments, the field or variable being observed, followed by the pattern that is being matched, which should be enclosed in double quotes. This function can be used in a search or rule to narrow the data set by placing it in the filtering statement of a search or in the event section of a rule, much like the function regex. It can also be used in the outcome section. The second function we're going to cover is so similar to strings.contains that it seems silly not to include it here. The strings.starts-with outputs a Boolean value as well. The only difference is that it matches a pattern from the start of the field rather than anywhere within the field. Syntactically, it's the same and can also be used in the filtering statement of a search, the event section of a rule, and in the outcome section. With both of these functions, it's a good idea to leverage the functions strings to lower or strings to upper to handle fields and values where there may be case sensitivity concerns. We'll look at some examples that take this into account. Let's start by looking at strings.contains. Perhaps we want to find command line process launch events that contained command.exe/c. This snippet indicates that a command is being executed within a new instance of the command prompt and then is immediately terminated once the command completes. While this can be used for legitimate purposes, a number of command and control platforms will leverage this method when executing commands on a victim system. We can build an initial search like this. The event type and product name focus our search on a subset of events, and we can turn our attention to the target process command line field. Because we don't know where in the field command.exe/c will be, we can use the strings.contains to find this pattern in the field. If we do, this line of criteria returns true, if not, false. Now, we specified a pattern that is all lowercase. What happens if command.exe/c is mixed or all uppercase? We don't want to risk missing any events, so we can add the function strings to lower to our criteria and nest it around the command line so that the value in the command line is converted to all lowercase first, and then the pattern is searched for within the all lowercase string. Now, when we run the search, we can see we're getting results returned. We could stop here, but what if we wanted to refine our search to provide some sort of summarized or aggregated output? We could do this by adding a match section and aggregating on fields like principal hostname and target process command line to get a listing of the unique combinations of host and command that contain command.exe/c within our search window that we could go ahead and investigate and analyze further. Let's shift to the strings.starts-with function. This time, rather than using the function in the filtering statement, we're going to use it in the outcome section and flag command lines that match our pattern as true and those that don't as false. Our filtering statement will focus our search on Microsoft Sysmon process launch events where the command line is not null. We can aggregate our results by the hostname and command line like we did previously. This time, we're going to add an outcome section to our search and use the strings_starts-with function to look for command line values starting with the pattern of C users. However, because we are aggregating our search, we need an aggregation function like max, sum, count, or array_distinct in our outcome section. Since max, sum, and count are all for numeric aggregations, let's use array_distinct. Notice we get an error now that says expect type enum int float string got type boolean. This is because our function outputs a boolean value, not a string or any of the other types. We can still use the boolean output in the outcome section by adding a conditional or if then else statement right here. Now, we're converting the command line to all lowercase and finding the pattern of C users at the start. And if that is true, then we'll output the string true. And if not, we will output the string false. With that change, we're in good shape. We're going to go ahead and sort the true strings to the top and limit our output and then run our search. In our results, we can see that we have a subset of command lines that were run from the C users folder marked true, and those events that did not start with C users are marked false. Could we have filtered the non-C users in the filtering statement instead? Sure. But sometimes when hunting or even just exploring our data, we want to go ahead and extract a broad set of data and apply a flag that might allow us to look more broadly and then refine our search further. Both of these searches could be adapted to rules. Let's take our last search and create a detection when executables are triggered from the users folder. Here we have moved our strings starts with function to the event section, and for our rule, we're aggregating by the host name over a 1-hour time window. If we get a detection on user execution in the C users folder, we want to generate an aggregated count of events that met this criteria during our 1-hour time window. We also want the names of the users who launched these processes. And finally, we want to get the first folder after C users in the events. Because strings.contains and strings.startswith output a Boolean value, we can't use these functions to output the folder name. Instead, we could use a function like recapture to extract that value from the command line and display it in the user folder outcome variable. In our results, we can see that many of the process launch events were executed by Dan Cooper out of the C users public folder, which could be suspicious. We can also see that during a different hour window, that Dan also executed processes from his personal folder as well as public. If the public folder under users is not used in the organization, that would probably be something to investigate further. The functions strings.contains and strings.startswith provide us the ability to match against a provided pattern either at the start of the field or variable or anywhere else within it. Either way, the function will provide a Boolean output. To use these functions, we require the field or variable followed by the pattern in double quotes. The functions strings to lower or strings to upper can be nice tools to use to ensure pattern matching in fields where values could be mixed case. Finally, this function can also be used in the filtering statement of a search, the events section of a rule, as well as in the outcomes section. Though remember, in the outcomes section, an aggregated function like max, count, array distinct is needed when aggregating events. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community URL detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.